Hey there, grade 12s. Here we go with the November 2021 past paper. Paper 1, starting off with algebra. We've got solving a quadratic equation, some marks that we must be able to guarantee. And this question is solved by a straightforward factorization. Okay, in the brackets, you've got to think of the two numbers that would multiply together to make negative 24, but add together to make 2. And that would leave us with x minus 6 multiplied by x plus 4 is equal to 0. That means that x minus 6 must be equal to 0, or that x plus 4 must be equal to 0. And solving each of these little equations, we'll get x is equal to 6, positive 6 there, excuse me. X is equal to a negative 4. And there we go. There are your two answers for question 1.1.1, and a mark for factorizing. So when examiners look at this, you would most likely get 1 mark for factorizing, and then you would get a mark for each of your roots. And that's where your marks for that question would come from. All right. Question 1.1.2 is also a quadratic, but when you see this clue, having to solve it correct to 2 decimal places, that means we're going to have to use our quadratic formula to get it solved. So remember that when we have a quadratic formula in the form of ax squared plus bx plus c is equal to 0, that means that x would be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that's something that you can find in your formula sheet, but just reading and writing it here for the sake of this video demonstration. Okay, so rearranging this 2x squared minus 3x minus 3, which is currently in the ax squared plus bx plus c equals 0 form, into the quadratic formula, we would find that instead of b, we would put negative 3. Notice how it's negative b. So here it would be negative 3. So you would need to write this in as a positive 3 or as a negative 3. Okay, that is something that could cause complications for you if we don't pay attention to that point. As well, in b squared, if you're including the negative 3, you must put it in brackets when you enter it into your calculator. Just as a side note, okay, as a little side note to this over there, just watch out. If you put in your calculator, negative 3 squared, that is not the same as negative 3 squared. So on your calculator, when you have to square a negative 3, this is the one we're looking for. That's the one we're looking for. Okay, carry on. So then we'd have negative 4 times the a placeholder here, which is 2. So negative 4 times 2 multiplied by the c placeholder, which is negative 3, is in the place of the c. This would be all over 2 multiplied by a, which is 2. And this is where we get out our calculators to help us out. So let me find the calculator here. Let's have a go. So to enter this in, enter first of all our fraction button. And remember, you must put a negative and put the negative 3 in brackets. Or you could just write it as a positive 3, which would be simpler in your fraction. So we could have, again, negative 3, or you could just write it as a positive 3, plus the square root of negative 3 squared. So minus 4 and AC. So 2. Forgive my slow clicking here. In an exam, I'd hope that you'd be able to move much quicker than this than I can with my mouse on the keyboard here. This is why I'm so bad at gaming. Terrible at clicking. I have to use a controller. Mouse and keyboard is not for me. 2 times 2, there we go. Okay, and switching to the decimal format, we see that our one answer is will be 2, and to 2 decimal places, that will be 2,19. Or our other answer, x would be equal to. Now what we have to do here is to go back, and we have to change that positive, which came from the plus minus. We have to change that positive to a negative. So instead of retyping this all into the calculator, let's just click our back button all the way and then change that to a minus sign. And let's click equals here, and changing that into its decimal form, we should get negative 0,69. Okay, and then we have it. We've solved question 1.1.2. Okay, now let's have a look where our marks would come from for this question. Yeah. This question, you would receive a mark for actually writing down the formula. Simple as it is, you get a mark for that. Many students don't, though. You don't write down the formula, but you would still get this mark if you show that you have correctly used the formula. They call it implied correct use of the formula. Okay, so if you didn't write down the formula here, you still would have got 2 marks for this section if you had correctly substituted everything in. And then you would get a mark for your answers, and that would give you your 3 marks for this question. Okay, moving on to 1.1.3. Here we have an inequality. Now, there's a lot of similarities between solving this inequality and solving a quadratic equation, but we must remember we're not actually solving a quadratic. We do, first of all, get this into its standard form, just like we would if we were solving a quadratic. That is a 5, by the way. I'll just correct that. So x squared plus 5x minus 4 is less than and equal to 0. Now, to find, we are not actually, I can't just say, right now, solve this as a quadratic equation, okay, and make that equal to 0. I can't just change it without indicating that I'm doing this to find the critical values of our inequality. So I'm finding my critical values of this inequality by setting the expression equal to 0. Then factorizing it, so that would be x. Look what I've done. Look at this mistake that I've made. That should be a plus 4 and a plus 4 over there. So this would be x plus 4 in one bracket and x plus 1 in the second bracket. Yeah. Okay, instead of just scratching over it, let me change that properly. Okay, let's recap, because we had a few stops and starts. We're solving an inequality. We first of all get the inequality into standard form, x squared plus 5x plus 4, all terms on the left-hand side, and easiest to have the x squared, the term with x squared in it as a positive coefficient. Here we've got a positive 1. Then to find our critical values, we set this quadratic expression equal to 0, find its factors, and then set each of those factors equal to 0. So x plus 4 would have to be equal to 0, or x plus 1 would be equal to 0. So that means the one critical value is x equals negative 4, and our other critical value is x equals negative 1. Now, you should not actually underline that, how I have done, because that would be indicating a final answer, and we are not at the final answer yet. Okay, now our critical values are x equals negative 4 and x equals 1. That means that negative 4 and negative 1 are the values where the outputs of our function change from being negative to positive or positive to negative. So imagine we're moving from left to right, putting in different x values as input values into this expression. And each of these input values are going to give a positive output value or a negative output value. When x is less than negative 4, we are getting positive output values. So each of these x values that are less than negative 4 are mapping onto positive output values. But here we are interested in which values of x map onto negative output values. So here are all our negative output values. So here are all our negative output values, and it is the x values that are between negative 1 and negative 4, or that is negative 4 because it's less than and equal to 0. So 0 as an output value is included. And all of these values that are in between negative 4 and negative 1, they all map onto output values that are less than equal to 0. So the values that we are interested in, the x values that we are interested in, are all the x values that are greater and equal to negative 4, and also less than and equal to negative 1. And there we have it. And there is our final answer for 1.1.3. Okay, let's have a look at where we get our 4 marks from this question. This inequalities are usually 3 marks. Here it's 4. And the first of those 4 marks you would get would be rearranging this inequality into its standard form. So there you go. You'd get a mark for putting this into standard form. Okay, then you would have another mark for finding the critical values, that critical value of negative 4 and negative 1. So you would get your 2 marks for finding each of those critical values. And then your last mark is for critical values. And then your last mark would be for a correct inequality statement. Yeah, question 1.2 has some simultaneous equations and 6 marks, a lot of marks that we can get for this question. These questions normally involve a linear equation with one variable being isolated and then substituted into an equation with a higher order. And then that equation being solved, now that has a single variable, and then substituting back to find your other variable that you haven't solved for yet. So looking first of all at the linear equation, we need to pick a variable that has a coefficient of 1 if we can, and isolate that variable. In this case, it's the x. Just makes it so much easier later. So isolating the x, we'd have x left on the right, and then 2y minus 3 on the left. You may prefer to write, it's probably easier, prefer to write it as x equals 2y minus 3. Now that we have the variable x in terms of y, we need to rewrite the variable x in the higher order equation and rewrite it as 2y minus 3. So here we have 2, and instead of x, we would have 2y minus 3 plus 7 is equal to, instead of x squared, we would write 2y minus 3 squared plus 4y squared. We've got some algebra to do. And look at the error that I have made. It's 2xy. So at the end of this bracket, there should actually be a y at the end. And it maybe just as well I made that little error. I can use that just to emphasize something. Let's write that. So 2 and 2y minus 3 instead of x. And you've got your y at the end. Now, we need to do algebra and dual algebra involved in simplifying these expressions. Something which may seem like a small thing, but can trap people, can catch students out, is having to multiply in the 2 first and the y, and trying to do that all in one go. What would make it easier is to rewrite this left-hand side as 2y, open bracket, 2y minus 3, and just multiply the 2y in one go instead of multiplying in 2 and then y. It's just something that could help avoid getting caught out and help you avoid some silly mistakes. Squaring the bracket on the right-hand side, 2y minus 3, all squared, would become 4y squared, that is a y, 4y squared, minus 12y plus 9, and then plus 4y squared. Expanding out the left, we would have 4y squared minus 6y plus 7 is equal to, tidying up the right-hand side, 4y squared plus another 4y squared, 8y squared minus 12y plus 9. Now let's get this into standard form. The larger coefficient of y squared is on the right-hand side, so I'm going to move everything to the right. We'll be left with 0 by the time we're done on the left, moving all of these terms to the right. 4y squared, positive 4y squared, so we subtract 4y squared from both sides. We'll end up with 4y squared on the right. 8y squared minus the 4y squared is equal to 4y squared. We've got a negative 6y, so I'm going to have to add 6y to both sides. Negative 12y plus a 6y ends up being negative 6y. Positive 9, we have a positive 7 on the left. We're going to have to minus 7 from that positive 9. So we will end up with 2 on the right. We can still divide this by 2 to make it even easier for us. So we will have 2y squared minus 3y plus 1 on the right-hand side. Factorizing, this would become, in brackets, it would be 2y minus 1 multiplied by y minus 1. Yeah, that means that 2y minus 1 must equal 0, or that y minus 1 must equal 0. Solving each of these little equations, we get y equals a half. And on the right, we'd say y equals 1. Okay, now we have found the two possible y values that would work in both of these equations, but they do have corresponding x values, which we do need to use. So we're going to go back and I'm going to use this linear equation, and I'm going to substitute each value of y in turn to find its corresponding x value. So let me just rewrite this on the space I have left on the right-hand side. So I've got x equals 2, and instead of x for the first time, I'm going to rewrite x as a half. So x equals 2 times a half minus 3. And this would leave me with x is equal to, well, 2 times a half is 1. 1 minus 3 is negative 2. So one solution is that when x is equal to negative 2, y is equal to a half. Now that is one of our solution sets. I've still got another to find. Let's say that when x is equal to 2y minus 3 and when y is 1, then x will become 2 times 1 is 2 minus 3, that will be negative 1. So another solution set is that when x is negative 1, y will be equal to positive 1. And there we have another solution set. So there are two solution sets. Let's have a look at where our marks for this come from. Now, I must again say the disclaimer. I am a maths teacher. I am not an examiner. I'm just saying where the marks came from on this particular question. Okay, so first of all, for isolating the x, you would have got a mark there. Okay, so for correctly isolating the value of x, you would have got there. For doing a correct substitution, for changing each variable of x into a 2 minus 3, you've got a mark there. Let's actually write what these down. That was for isolating. So for isolating x. If you had isolated y, you would have got the mark, but it would have just been harder work for yourself. And here you get a mark for substitution. Okay, for correct substitution. And then simplifying this all down and getting your equation into standard form. There we go. You will get another mark there. So that's 3 marks already for standard form. Now, if you make a mistake along the way, that doesn't mean you've lost everything. Keep going because you can get consistent accuracy marks. Okay. This standard form mark should have actually been given down at the bottom where it's completely in its simplified form, where you've taken out divided by 2 on both sides. Okay. Then for factorizing, you would get another mark. And then you would get a mark for your y values, getting your correct y values, and then getting each of your correct x values. You would have got a mark there. So this mark here was for factorizing. Excuse my writing. And your mark here was for y values. And your other mark here was for your x values. Okay, question 1.3 involves proof and requires an understanding of the nature of roots of a quadratic equation. The question reads, the roots of an equation are x equals negative n plus or minus n squared, the root of n squared minus 4mp all over 2m, where m, n, and p are positive real numbers. The numbers m, n, and p in that order, it's important, form a geometric sequence. Prove that x prove that x is a non-real number. Okay, we're just going to put a little side note to begin with. The question is asking us to prove that x is a non-real number. What would make x non-real? Okay, and this is the key idea here, that if n squared minus 4mp, in other words, the discriminant of this equation, if that discriminant is less than 0, then we could say that x is non-real. Why is that? Because if n squared minus 4mp were less than 0, that means you would have a negative value underneath a square root sign, which would produce a non-real number, the square root of a negative number. So that's what we have to do with this question. We've got to show that n squared minus 4mp is less than 0. Okay, how are we going to do that? Well, the first fact we're going to use is that m, n, and p form a geometric sequence. So let's just state that. Okay, m, n, p, and so on and so on and so on is a geometric sequence. And what do we know about geometric sequences? We know that they have a common ratio, that whatever we times m by to get n is the same thing that we times n by to get p. So that means that n over m is in the same ratio as p over n. And that will allow us to set up a little equation. Through cross multiplication, we would get n squared is equal to mp, which then allows us to say that n squared minus mp is equal to 0. Okay, now this is looking similar. It has some similarities to our discriminant, but the discriminant has a 4 multiplying the mp. Let's have a look at this. N squared minus mp is equal to 0. And m and p are positive numbers. So that means we could now safely say that if np minus mp equals 0 and mp are positive numbers, then we could for sure definitely say that n squared minus 4mp would be less than 0. Okay, and how do we know this? Is because n, m, and p are positive. Are positive. Okay, so n squared minus 4mp will be less than 0. Okay, and we can finish off squeezing it in the corner here. You obviously on your page use your space a bit more wisely than I have. Therefore, we could say we must finish off with a statement that x is non-real. Okay, a 4-mark question. Okay, let's have a look at where we would get our marks from. Now, I'm going to give some guidance on where the marks could possibly come from. First of all, setting up the equation of n over m equals p over n, using the fact that m and p are the first terms of geometric sequence to form an equation, there we go, we get a mark. Okay, to cross multiply and to get n squared equals mp, we would, and then to simplify to n squared minus mp equals 0, we'd get a mark there. Now, your statement and the reason that therefore n squared minus 4mp is less than 0, that there would get a mark. and then your final statement, your conclusion drawn, therefore X is non-real. There we get your final mark. So that just shows you where your 4 marks for this question, well, this is one way that you could earn your 4 marks for that question. Really hope that's helped. All the best with your future exam preparation.